Okay, so now we will study here the gas law. Okay, pressure or gas pressure and the gas law. Okay, we will discuss in this chapter um, gas law and gas pressure. So now let's say it start from the gas. Um, so gas pressure and the gas law. So in this chapter we'll study these things. We will relate the volume, temperature. We will study the ideal gas and the other gas law, stoichiometry of the gases, effusion, diffusion, and finally the kinetic molecular theory. Okay. So let's discuss first of all what is the pressure. Okay, pressure can be exerted by gas, it can be exerted by liquid, and it can be exerted by solid. So whatever the pressure exerted by what type of the phase is, but the formula is basically same. Pressure is equals to uh, force per unit area. It's force divided by area. That's the pressure. For example, atmospheric pressure arises because of the pressure exerted by the atmospheric gases or the force exerted by the atmospheric gas on the surface of the earth. That the atmospheric pressure. Similarly, gas pressure means that the gas pressure in the vessel, for example, any cylinder. So pressure exerted by that gas is the gas pressure. Similarly, liquid pressure also. It could be also. So the pressure exerted by liquid is equals to the force exerted by liquid particle on the surface where they are following. So that's the um, liquid pressure. But we will discuss here only the gas pressure. Okay. So now before studying the gas pressure, let's understand the units of the gas. Okay. So before understanding the unit of the gas, let's know that how do you measure the gas. So to measure the gas, we use two type of the instrument. One is the barometer. So let's say suppose the mercury barometer. We may have barometer of other liquids also, but let's think about the mercury here. The mercury barometer, and the other is the manometer. So how this barometer measure the pressure? It don't measure the pressure of the gases, but it measures the pressure of the atmospheric gas. So atmosphere pressure. So that atmospheric pressure uh, uh, is equals to rho gh, rho gh. Rho is the density of the particular liquid here. So whatever the liquid we are looking here, and g is acceleration due to gravity, and h is the height of the this liquid. So to measure the atmospheric pressure, we use the mercury barometer. And how that mercury barometer works, look at the dish here, one dish here, and that dish has the filled mercury up to here. See up to here the mercury. And we have a long tube, so that tube has a vacuum basically, and if we invert that tube on the mercury, atmospheric pressure press down, atmospheric pressure from the each point on the surface of the mercury, right? Because the atmospheric gases are everywhere, that all these gas will press from here, from here, from here, from here, from here, right? So these gas will press that mercury. And because of the pressure exerted by these atmospheric gas particles, then mercury will fill up to here in that tube, and it will rise, that mercury level will rise it up because this is the vacuum. This is the, so vacuum means that vacuum has no pressure, that's why easily mercury will go up. So at the sea level, that total height obtained by the mercury is 760 millimeter. So that's why we measure the atmospheric pressure in the one unit is 760, and the unit is the millimeter of mercury. So that's why in that tube about 760 millimeter mercury will rise up, because this tube is about more than a meter long. That's why its total rise, this height is 760 millimeter. That's why we say 760 pressure, atmospheric pressure is equals to 760 millimeter of mercury. So how does it work? It works on the Pascal's principle. So what the Pascal's principle says, that this principle states that pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the container. For example, if you apply the pressure here, it will apply the pressure here also, in this wall also, side also, everywhere. So it based upon this principle. So if you give the pressure here, then no way to go, and the pressure will be always apply on this direction also, and the mercury will rise up. So this is the atmospheric pressure. So manometer, the barometer is used to measure the atmospheric pressure. Okay, so now uh, that's the atmospheric pressure. But how do you measure the gas pressure in the container, in the vessel? Okay, for example, gas pressure in your tube, tire tube, or in your cylinders, anywhere. So, how do we measure that? We measure that pressure using the manometer. So again, it is a mercury and it is a U-tube. Just simply see that it's the U-tube. Here is a valve. This is the gas. Maybe it may be cylinder. It may be your tire tube or whatever. This is the vessel. Okay. And if you open the valve, gas will flow in this direction, right? And it will press down this mercury level, and mercury level will rise up. So initial mercury level was that, and after gas opening, so gas press that down, and because of the pressing by gas, you have a new height is that. So this is the manometer, very simple. So but the manometer can be two types. One is the closed end manometer, and in the closed end manometer you see that this is the vacuum again, same as like the barometer, this is the vacuum. But the open end, there is no vacuum, because the open end you may have atmospheric gases there, atmospheric pressure. That's why other is the open end. In the closed end, there is no any atmospheric effect of the atmospheric pressure, only the effect is gas pressure. That's why gas pressure is equals to pressure of the gas is equals to pressure at this level. Okay, pressure at, let's say, B, pressure at B, and pressure at B is only due to this column, right? This much height of the mercury. That's why rho GH. So that's why in this case rho GH. But open end, that's happening other way. So you have a one opposing force also. From here, gas will open, and gas will start pressing that down. But you have a atmospheric pressure also, that also pressing down, right? From here also press, here also press. That's why that will win which is more. For example, if the atmospheric pressure is more than the gas pressure, then it will go down, right? Because the atmospheric pressure will press it down and it will go back. So it will rise the, so initially it was this initial, this was the initial. After atmospheric pressure is more than the gas pressure, that's why atmospheric pressure will win, and then that will press that. So pressure at A, so what is the total pressure? Pressure of the gas is equals to, pressure of the gas is equals to, so this is another pressure of gas, right? This is the total, is the pressure, atmospheric pressure. So, and a PATM minus rho GH. So because we have to subtract that. So this is the, if it is the open end, uh, the gas pressure is, if gas pressure is less than atmospheric pressure. But if gas pressure is more than atmospheric pressure, you have to add that, right? Gas pressure is from here, atmospheric pressure is from here, but the still you are rising this much, means that P8 atmospheric pressure plus rho GH. So that will be in that case. How do you know that which is more or less? Well, if this height is more than 760, then that means that it is the case of P gas is greater than PATM. If P gas, if the height, whatever the height is less than 760, and it means that if less than 760, it means that it is less than PATM. So that way we measure the pressure. Okay. So now we have a common unit of the pressure. Okay. Now what are the units? Let's see that one is the Pascal or kilopascal, ATM, which is atmosphere, millimeters of the mercury, which is mm of Hg, okay, and then torr, other unit is torr, and then other unit is the square inch per, okay, pounds per square inch. How much pound of the force is applying in 1 inch squared, and that is also said to be the psi. Okay, pound per square inch. Pound per square inch is the psi. So, and a fourth unit, other unit is 1, 2, 3, 4, 5, sixth unit is the bar. So these are the units. Okay, generally we use in the chemistry. So Pascal, let's compare them all with the atmosphere. Okay, so take one atmosphere. One atmosphere means 1.01325 times 10 to the power of 5 Pascal, or 101.325 kilopascal. 1 atm. 1 atm means 760 mmHg. 1 atm means 760 torr. 1 atm means 14.694 pound per inch square, or psi. And 1 atm is equals to this much bar. So that's the relation between those units. Okay, now let's do one example. So converting unit of pressure. Okay, geochemist heats limestone, calcium carbonate, which is the limestone sample, and collects the carbon dioxide released in an evacuated flask attached to the closed-in manometer. Okay, after the system comes to room temperature, delta H equals to this much. Calculate the CO2 pressure in torrs, atmospheres, and the kilopascal. Easy, right? So let's see that 760 torr is equals to 760 mm of Hg equals to 1 atm equals to 1.0135 bar. So they convert that. So 291.4 mm of Hg divided by 760 mm of Hg times 1 atm. This cancels. So whatever the value of this, it's about 3, and that is in the atm. Similarly, you can convert into torr. So 760 torr is equals to 760 mm of Hg. So that's why 291.4 mm of Hg is equals to 291.4 for torr. So that's the unit conversion, one example. So now let's go to our actual topic. That's the gas law. Okay, we will study the gas law intensively in this chapter. So first of all, we should think about the ideal gas and what are the non-ideal gases. Okay, so ideal gas is that gas which is a point particle and which don't interact with any other particles, other gas particles. It can randomly move, but it don't attract or repel by any other molecule around itself. So that's the just the assumption. Actually, in the nature, we don't have the ideal gas. So, but a model to study a simple model for the gas is, let's first of all think about the simple model, that is the ideal gas law. So we use the ideal gas um, on that ideal gas law. So then what are the gas laws? Gas laws are the laws, the relationship between pressure, volume, temperature, and the number of moles. You have a 4 thermodynamic variable um, related to the gas. One is the gas has pressure, other gas has volume, other gas has temperature, other is the number of moles. So relation between these is actually the gas law. Okay, so the relation between these, and using those relation we study the behavior of the gas. Okay, so that is the gas law. Gas law means relation between these 4 variables, and those relation are said to be gas law, and they actually tells about the behavior of the gas in different conditions, different temperature, different pressure, different volume. So it tells you about the um, about the behavior of the gas. That's the gas law. Okay, so we will study further in the next slide.